In this problem, we are given this diagram right here. We are also given this table right here. Then we are asked to calculate the power derived in this circuit. This right here is our circuit, and these are the voltages and currents that flow through each circuit. We have our P delivered and our P absorbed. P absorbed is represented as a P with a plus in parentheses like this. And then P delivered will be a P and then a negative sign inside of parentheses like this. We have to analyze each individual circuit and see if it is a positive value or if it's a negative value. These are the indicators for positivity and negativity. This indicates if it's going to be a absorption or a delivery. These negative signs do not. They do in a way, they indicate kind of direction, but these are what we're going to have to look at with the negative signs in here. So first we are going to look at A. So we have a negative side of our voltage, and then we have a positive right here. If we look at our notes, there is a drawing in there with two terminals that look something like this, where we have our circuit like this, and then we have a 1 going in this way, and then we have a 2 going out this way. So we have our 1 and we have our 2, and this is our voltage. And we know that our voltage is going from plus to minus, and then our current is going this way. This is positive because it is going through the plus and out the negative of the voltage. So when we look at part A, we are looking right here. Our voltage is positive and our current is positive. So we are going to just look inside of here. We can see that we have a positive and a negative. Then we look at our current right here. Well, our current is going from negative to positive. It's going through this voltage from our negative side into our positive side. What this means is that it is being delivered, not absorbed. Because if it was absorbed, it would be a plus. And for it to be a plus from our notes, we know that the voltage and the current have to be going in the same direction. We can also look at this down here to help us determine what it is. So for part A, we are having a delivery of power. For part B, we are going to do in blue. We have a 14.16 and a 4.72. We have no negative signs in here, only positives, so we're just going to look at our circuit. Looking at B, which is right here, we have a negative to a positive. So our voltage is going this way. It's going into the positive and out of the negative. Now we see that our current is going the same way. That means this has to be a plus. So since it's an absorption, we're going to write it down here. PA is plus, so this 14.16 times 4.72. And we're going to add this to whatever's next. Now we are going to look at part C. We'll do this in green. We have a negative 32 voltage and a negative 6.4 amperes. If our voltage is negative, that means it's actually going to be entering through the negative and out the positive. It's basically the reverse. Everything that we've done previously, it's supposed to enter through the positive and out the negative, but since it's negative, our voltage is going to be going this way, into the negative and out of the positive. Our current now is going to be going in the negative direction. Now, from here, it looks like our voltage and current are going in the opposite direction. However, if we look back at the table, we see that we have a negative 6.4, and since it's a negative 6.4, it's going to be going this way for the current. Technically, it's not going this way. We have to look down here. We have a negative charge. It's not really changing direction. We just have a negative charge flowing instead of a positive charge. So for our voltage, we technically have a voltage drop from terminal 2 to terminal 1 because our terminal 2 is the negative side. So we're going from negative to positive. So it is a terminal drop. And then for our current, we have a obviously negative charge because it tells us this in the table. And we can see that this negative charge is flowing because of the actual arrow. This is the actual arrow. We're not looking at this right now, but we're looking at the actual current that they give us. It is going to the right. It's going from positive to negative. So we have a negative charge, which would be this, flowing from terminal 1 into terminal 2. This charge is negative, this voltage is negative, so this will be the direction, these two right here. And since they're both going in the same direction, it's going to be an absorption. So we are going to have C being 32 times 6.4. We don't include the positive or negative signs in here. We just have them all being added or multiplied and then added together, because the negative sign and positive signs in our table, it only indicate the flow of current or voltage drop or rise. When we look at part D, doing it in black, we have 22.0 and 1.28. We have no signs here, so we're just going to look at it. We see that our voltage is going from positive to negative down this way, and then we see that our current is going the opposite way. Since our current is going the opposite way of our voltage, we know that this is being delivered. Since it's being delivered, we are going to have it added up here. Next, we have E, which is 33.6, and then we have 1.68 here. No negative sign, so we're just going to look inside of our current. Our E is right here, so this is where we will be focusing. For our E, we have our voltage going from positive to negative. We know this, so it's going to be going in this direction. Our current is going in the opposite direction. That means it's being delivered, so it'll be a negative and it will be a P delivered. Next, I'm going back to red, and we are going to do this F. We have a 66.0 and a negative 0.4. So we are going to have a change in our current that we're going to have to look at. So looking at F, our voltage goes from positive to negative. So it flows into the positive, out through the negative, meaning it's going to go this direction. First glance, our current looks like it's flowing in the same direction. However, since it's negative, the actual part that we're looking at is going to be going in this direction. Since they're in opposite directions, F is negative. I'm going to expand on this more because it's super important to know. The voltage drop is going from terminal 1 to terminal 2, because our terminal 1 is a positive value and our terminal 2 is a negative value. So it goes from 1 to 2. And it tells us this right here: the voltage drop from terminal 1 to terminal 2 is a positive value right here. Another way to note the differing directions from here and here is to look at the original current direction, which is actually going this way, except it's negative. Again, that's why we flipped it. But if we were to look at it with it going down this way, we would be saying that it is going from the first terminal to the second terminal, and it's a negative charge. So we would be looking at this again. We would be looking at the negative charge flowing from terminal 1 into terminal 2. And that is what this current is. Next, we are going to be looking at G. And since they are going in separate directions, we are adding this to the delivered. Next, we are going to look at G, which is going to be in blue. We have a 2.56 and a 1.28. Both are positive, so we're just going to look at it how it is. We remember that voltage drop, if it's positive, it's going into the positive side and out of the negative side. And if the current is the same direction, which it is in this problem, it is going to be a plus, meaning it is absorbed by our circuit. So it is going to be added in down here. Lastly, we have an H, and for our H circuit, we have a negative 0.4 and a 0.4. So the only thing that's changing really is our voltage drop. So since it's negative, instead of it normally going from positive to negative, again, this is how it normally is, it's actually going to be going from negative to positive if we're just looking at it from drawings. We have the voltage drop from terminal 2 to terminal 1. And since our current is positive, it's still going to be in this direction. Since they are both in the same direction, it's going to be a plus, also known as absorbed. So we are going to add it down here as it is absorbed. Now all we have to do is plug all of this into a calculator. Remember not to use any of the negative signs that we were given in this table, because all they do is indicate voltage drop or rise, or the positivity or negativity of the charge flow. And after we plug both of these into our calculator, for the PD or P delivered, this is the negative value, or the voltage and current going in opposite directions, we are going to get 387.968. And this is going to be in watts because we have voltage times amps, and this equals to a watt. If we plug this lower part, which is PA or P absorbed, we're going to get the value 275.072 watts. And so this is the answer to the first part. Now, are the measurements in the table P1.28 valid? We have to see if this is true or not. And to do this, we need to look at the absorption and delivery. So when we have our circuit like this, we know that power is going out of it, like a car battery. So we have the wattage going out, and then we have wattage coming in. When we start the car, we are delivering power, and then when we're running the car, we are charging the battery. Well, when we are delivering power, we are delivering negative 387.968. I don't know why this is duplicated. This should only be written once. But we have this being delivered. Now our power that is being absorbed is 275.02. And these are both in watts, like this. Well, the reason why our measurements in table P1.28 are invalid is because we are delivering more power than we are absorbing. So eventually our battery is going to run out of wattage if it was like this. We don't have enough wattage from our actual battery to sustain this power delivery. So are the measurements in table P1.28 valid? The answer would be no. And it is because our delivery is greater than our absorption. I did make a super important error when I was writing out the delivery and absorption right here, and I actually corrected myself right here, and I didn't even realize it. But the delivery, as it states in the instruction right here, is denoted by a negative. So when we write this answer in here, it should have a negative. And the P absorption would be a positive, but we don't usually put a positive in front of a positive number. We just know it's a positive by it not being negative. However, for our delivery, we do have to note, and it's super key, that we know that we have a negative in front of this. And that is the answer, negative 387.968 for the delivered power, 275.02 for the absorbed power, and no, the measurements in our table are not valid, as well as the work that we did to solve this problem.